boys and girls, this is Mr. Cusick, and welcome to part 2 of factoring polynomials using GCF. So in the last video we looked at using GCF with just 2 terms. We're literally doing the same thing here, except we're just utilizing it with 3 terms. So if I look at number 15, we got 2x squared y minus 2xy squared plus 4xy. Still doing the same concept, except now you're finding what's the GCF, or what's the biggest number that goes into 2, 2, and 4 evenly. Well, your answer would be 2. Now look at the variables. I have an x squared on the first term, an x on the second term, and an x on the third term. So the most x's I could take away is just 1x. And then with the y's, I have a y squared, and y. So the most amount of y's I can take away is just 1y. So I divide each term here by 2xy. So what's left over? 2 divided by 2 is 1. X squared divided by x is x, and the y's cancel. Okay, minus 2 divided by 2 is 1. Looks like the x cancels here, and then the y squared divided by y is just y. Plus, now 4 divided by 2 is 2, and the xy's cancel. Okay. Let's look at number 16. I have 9, 18, and 24. And at first glance, you might say, oh, the greatest common factor is 9. However, even though 9 goes into, obviously, 9 and 18, it does not go evenly into 24. So actually, the greatest common factor of the 3 terms is 3. 3 is the biggest number that can go evenly into all 3 terms. Now, look here. We have r to the 8th in the first term, r squared, and r. So the most number of r's I can take away is just r to the first. Now, if I look here, there's an s in the second term and an s squared in the third term, but there's no s in the first term, so I can't take away any s's. So the only thing I'm dividing here is a 3r in all 3 cases. So 9 divided by 3 is 3. R to the 8th divided by r is r to the 7th. Minus 18 divided by 3 is 6. R squared divided by r is r, and then we still got this s. Minus 24 divided by 3, 8. R divided by r's cancel, and I'm left with s squared. See, it's not really any different than what we were doing before, except we just got to worry about 3 terms. How about number 17? Again, we got 6, 14, and 10. The biggest number that can go evenly into all 3 is 2. I have a y to the 4th, y cubed, and y squared, so the lowest exponent is y squared. So 2y squared, I'm dividing everything by. So 6 divided by 2 is 3. Oops, y squared. Y 4th divided by y squared is y squared. 14 divided by 2 is 7. Y cubed divided by y squared is y. Minus 10 divided by 2 is 5, and then the y squares cancel out. All right, let's look at one where it has those 2 variables again that we're factoring out, even though we looked at one with 15. 18, 12, 36, and 6. The biggest number that can go evenly into all 3 terms is 6. I have a to the 5th, a to the 4th, a squared, so the greatest common factor would be a squared. B squared, b cubed, b squared would be b squared. So divide everything by 6a squared, b squared. Twelve divided by 2 is 6. A to the 5th divided by a squared is a cubed. B squares cancel. Next one, 36 divided by 6 is 6. A to the 4th divided by a squared is a squared. B cubed divided by b squared is b. And the next one, everything cancels out, so I'm left with minus 1. If I look at number 19, the greatest common factor of 14, 28, and 14 is 14. There's not a g in all 3 terms, so I can't, do that. But there is an h in all 3 terms, so I can factor on h. So divide each term by 14h. 14 divided by 14 is 1. There's a g. And h squared divided by h is h. Plus 28 divided by 14 is 2. There's a g. and the h's cancel. And then the whole last term cancels, so I'll put plus 1. All right, let's look at, I feel like I'm repeating here, but let's look at number 20. Okay, what's the greatest common factor of 18, 24, and 36? You'd be correct in saying the answer is 6. I have an x squared only in 2 of the 3 terms, so that's not a greatest common factor. The same thing for the y. There's only a y in 2 of the 3 terms, so that's not a greatest common factor. But there is a z in each term, so I can factor out a 6z. So divide everything here by 6z. 18 divided by 6 is 3. This x squared y still stays into play, but the z's cancel. Minus 24 divided by 6 is 4. There's still an x. And then z squared divided by z is just z. Plus 36 divided by 6 is 6. We got this y. And z cubed divided by z is z squared. Right, let's look at number 21 here. Now the numbers here are 1, 1, and 5. So that means the greatest common factor is 1. So I don't worry about the numbers, but I gotta worry about the variables. There is at least an m in each term. I look at the smallest exponent, it's just m. There's also an n in each term, but the smallest exponent is just 1, so just an n. So I gotta divide each term by mn. What's left over? Well, m cubed divided by m is m squared, and then the n's cancel. M squared n squared divided by mn is just mn. And plus 5, m's canceled, and n cubed divided by n is n squared. Okay. Let's skip to 24 here. If you could do 24, you could basically do any of these problems here. So 24, 3, 9, and 15. What's the greatest common factor? Well, 3. First term has an a cubed, a squared, and a, so the amount of a's I can take away is just a. Look at the b's. I have b squared, b cubed, b to the 4th, so I can take away b squared. And then I have c squared, c cubed, so I can just take away a c. So 3ab squared c. 3ab squared c. 3ab squared c. All right, so 3 divided by 3, 1. A cubed divided by a is a squared. B squares cancel, and the c's cancel. Minus 9 divided by 3 is 3. A squared divided by a is a. B cubed divided by b squared is b. C squared divided by c is c. Plus 15 divided by 3 is 5. A's canceled. B to the 4th divided by b squared is b squared. C cubed divided by c is c squared. And that, ladies and gentlemen, is how you factor polynomials using GCF. I actually want to go back to, what number was I here? Number 16 with the 9, 18, 24. When you're doing that by hand, 9, 18, 24, and you're trying to figure out the greatest common factor. Again, list all things that multiply, give you 9. So 1 and 9. What else multiplies? 3 and 3. So there you go. Those are your terms here. So you do 18. 1 and 18. What else? 2 and 9. What else? 3 and 6. Do 24. You have 1 and 24. 2, 12. 3, 8. 4, 6. So then I look here. Okay, none of them have, 2 of them have 9s, but they all don't. So the biggest number that's in all 3 was 3. Okay. So that, ladies and gentlemen, is how you do like I said, factoring polynomials using GCF. So what I would like you to do for homework is, I would like you to do all the odd problems here on the homework page. Again, if you have any concerns or any questions here, please feel free to message me. This is Mr. Kiesik, signing off.